All right, everyone, welcome to our week one live classroom of CIT160. It's good to have you guys, and I'm excited for this semester. Today, here's kind of what I was thinking for the schedule. I wanted to go over a couple of things in the class, look at some things in iLearn real quick, look at Slack, make sure that everyone's good to go there, show you guys where I'll post all the recordings for these live classrooms, and then I'll cover chapter one, your reading for this week. So, first things first, let's go into iLearn. So if you log into my BYUI, or if you log into byui.edu, let me go ahead and share my screen real quick. Share. All right, can you see my screen?
Yes.
Okay, awesome. So if you log into BYUI and then click on iLearn, you'll see all of your courses come up, all the courses that you're taking. So go ahead and click on CIT160. It might not be this beautiful pink. I made it pink for mine. You can make it whatever you want for yours. But you click on 160 and here is our course, all right? You'll see the most pertinent announcements, our most recent announcements pop up right here. Every week, if you look in our syllabus, you'll see that there is an extra credit opportunity every week of this course. Okay, so very frequently I'll get students around week 7, 8, or 9 who are like, hey, I really want to pass this class. Is there any extra credit? I'm like, yeah, but you've already missed like half of it. So don't be in that boat. If you click on the week 1 announcement, there'll be an announcement at the beginning of every week. It talks about this ongoing extra credit opportunity. There's a spiritual message, and all you have to do is just hit reply down here and write some of your thoughts. You can answer these questions if you want to. You can talk about anything else related to the message that you'd like or any thoughts that you had. But that's how you get extra credit. You can get 1 point for commenting yourself and then 1 point for responding to one of your peers. So that's 2 points a week. Some of your assignments are only 4 points. So if you do that for 13 weeks, that's a pretty good chunk of extra credit. So be aware of that. Going back to the home page, I'm trying to see if there's anything else here. As far as navigating, I know this is the first time being in iLearn for some of you. This is your first semester after Pathway or first time working on your degree with BYUI. So you can hit start here, that's fine, or you can just click on week 1. They'll take you to similar places. I usually just click on modules right here, but week 1 will take you to the modules page. You can see it loads modules up here, and then it'll just kind of default to whichever week you clicked on. All right, so a lot of different ways to navigate this thing. But yeah, so looking at week 1, we don't have too much going on this week. This is kind of an introductory week, which is nice because we only have a few days since we started on Wednesday. But orientation to online learning, a syllabus quiz, we'll look at that here in a second. Download and install software. Let's go ahead and look at that real quick. So what do you need to install? You need Google Chrome and a text editor. Okay, so this is not a very program heavy class for your computer, which is nice. Most of you will have a good browser. I recommend Google Chrome because all of the developer tools that I will be teaching you in a few weeks are in Google Chrome. All right, Edge, Internet Explorer, Firefox, Opera, they all have developer tools, but the ones that I will be teaching you are in Chrome. So I recommend that you get Google Chrome. As far as a good text editor, Sublime is fantastic. I have that on my computer and I use it for a lot of stuff. For this class, I will be using VS Code. All right, once you download it and install it, it'll look something like this. You can go into it. It'll do some nice syntax highlighting for your programs, and it's kind of like Word for an English class, okay? Where you would use Word to write up papers for other classes, use a text editor to write code in a programming class. All right, and any of these will work. If you're like, oh, well, I want to be rebellious and do Atom or whatever, that's totally fine. You can use whatever you want. But for all my videos and things, some of my older videos might be in Sublime, but my live classrooms and things like that, I'll use VS Code. So if we move right along down the line, let's see what else we have going on this week. Online typing tutor, nice. If you want to get better at typing, there for you. Getting to know you discussion board. So there is a channel in Slack called Week 1 Getting to Know You. So I sent out a couple emails last week talking about Slack. This is really important because we will not use email in this class. We will not use iLearn messaging. Notice I have this little inbox thing right here. We're not touching it this semester, not for this class. And there's also a bunch of discussion boards that are frequently in iLearn classes that we also are not going to worry about. Instead, we are going to use an application called Slack. All right, now I recommend that you download it on your computer. There are Mac OS and Windows versions of this application that you can download. And it's really nice because it'll keep you signed in and everything. You just sign into your computer, you can open up Slack, and everything is here in addition to it sending out notifications and things like that when things change on here. But let me show you a little bit of how we're going to use Slack this semester. So when I log in here, first thing I want you to do is go to your profile and account. All right, in here you can edit your profile. You can upload an image, which I would like you all to do, just a picture of yourself so we can see your face, and your name. Make sure this is your real name. I love stuff like Pikachu just as much as the next guy, but make sure it's your real name so you can actually get credit for things that you do. You don't really have to have any of this stuff, any of this other stuff if you don't want it, but at least your name, your full name, and your profile photo, okay? After that, you see we have a bunch of channels right here. You should be seeing these by default. If not, you can always search for them to find them. We'll have a peer review discussion board for every week of the course starting in week 2. But these top 3 are kind of what we'll use throughout the course for all general course matters. So this general channel is anytime I'm going to post like an announcement outside of the weekly ones with the spiritual messages and iLearn, those will be here. Any class related stuff I'll post here. You know, I posted here that, you know, we're going to have our live classroom at this time today, things like that. All right. Anything related to the class in general. If you have questions about iLearn, if the link's not working, or different things like that, you can post them here in the general channel. Okay. This help channel is when you're struggling with an assignment. All right. So if you're working on Robbie the Robot next week and you have no idea how to do it, you can post here and be like, hey, I don't really know what I'm doing with this, or I tried this and it's not working, or I can't find the assignment. This help channel is focused on assignments. All right. And what's really nice is I can come in here if someone like posted a question. This isn't a question, but I could click on the start a thread button and be like, oh, this is great, or whatever. And it'll show up as a reply underneath that post. And so it's really easy to keep everything nice and organized as far as answers to questions go. And then if other people have the same question, they can see that someone else asked it and get help. So this is really nice in that regard. I also posted this here. Everyone looking for general help, make sure to use the video spreadsheet, and you can set up a one-on-one appointment with me at any time. Okay, these are going to be really important throughout this class, so please be aware of these. Bookmark these links if you would like. I'll go more into the spreadsheet here in a sec. The random channel, any good jokes you have, I love jokes. Anything else you want to talk about, it's totally cool. Recipes, whatever floats your boat. That's what the random channel is for. Okay, getting to know you. A lot of you guys have already posted on here on the getting to know you, and it's been super fun reading your guys' introductions and everything. Same thing on here. You know, we have a bunch of people replying to Sam and to Benjamin, and it's great. We can all get to know each other on here. So that's for this week. And then next week we'll have our peer review discussions for the rest of the semester. Okay. Outside of that, we have our direct messaging. If you ever want to send me a message, just hit this plus button, and then you can just type in my name and click it, and then you can send me messages. Or if I wanted to send Colt Fleming a message, I could just search for him and click on it and send him a message, and it'll save those messages throughout the semester, which is also nice. So any questions about Slack? Any questions at all? I will take silence as I know. So last thing that I'm going to show you here in the help channel, I posted this link for the video spreadsheet. All right, if I click on that, this is also in your syllabus. Okay, but there is a link right here, installing and using Slack in the course. So I didn't go over how to install it or how to sign up or anything. If you need help with that, this video is for you. Okay, if you want to learn more about VS Code and Sublime, these text editors, and which one you want to use and how to use them, a couple of cool tricks, you can watch this one. If it's your first time using iLearn, or if you want to learn more Sublime hotkeys, these ones will kind of be later on in the course, how to use the Chrome developer tools. This one, week 5 tips, obviously is for week 5. But these videos will be very helpful for you throughout the semester, okay? And these first few, especially in getting set up this week. All right. These programming exercises are cool because every chapter that you have has a bunch of programming exercises at the end of it. And those programming exercises also contain your assignments for that week. All right. Now, these completed programming exercises are very similar to your assignments. They're not your assignments. Sorry, guys. But this exercise 1 of chapter 3 is really similar to exercise 2, which is your assignment for week 3. All right. And I can watch this start to finish. You can see me doing it and see how I did it, how things are working, and it'll be really similar to your assignments. So these videos are very helpful for you. And if you ever get stuck on an assignment, you can watch the exercise that I did from that chapter, and it'll be similar, have similar concepts and components that your assignment will have to have. Okay. The assignment introductions, notice that these are locked, so are the assignment walkthroughs. All right, these will become unlocked the week before an assignment is due. And the assignment walkthroughs will become unlocked after an assignment is due. So the assignment introductions, I would always get lots of questions on assignments being like, oh, I don't know how to do this, or I don't know what this is. And so these assignments are just a couple of minutes of me basically saying, here's what the assignment is asking, here's how I would get started on it. All right. And sometimes I'll write a few lines of code to kind of like help you get started. But then I'll stop the video, upload it to YouTube, and then I'll start up a new video and I'll finish that programming assignment and I'll upload that to YouTube, and that'll become unlocked a week later. All right. So if you struggled on the week 5 assignment and you had no idea what was going on and you got an F on it or whatever, then you could go in, you know, the week following that it was due, the following Monday, and it'll be unlocked, the walkthrough of it, and you can look at it and see how I wrote the entire assignment. Okay. So these 2 columns are completely for you to help you with your assignments. And specifically, you know, your programming assignments for each week. These will introduce the assignments, and these will show you my solution for the assignments. Now, if you're completely comfortable with the assignments, you never have to look at these. That's totally fine. But if you want help getting started on the assignments, or you want answers on what you did wrong in the assignments, or how you could have done better, watch the walkthrough assignments or these walkthrough videos, right? Because I have these videos, I won't give too much feedback on your weekly assignments. All right. So if you have specific questions after watching these walkthrough videos, just shoot me an email or a message in Slack, and I'll be happy to answer any questions you have. So, and then over here we have our live classroom column. All right. This is the link for this week 1 live classroom. It's obviously not there yet because we're doing it, but this is where I will post all the links when they become available after our recordings. So. And then we'll have our exam preps and exam walkthroughs that will also be available to you. Okay, so definitely bookmark this. Like I said, it's in the syllabus. In iLearn, if you go to this left-hand column over here, you can click on syllabus and you can see important things to bookmark, video spreadsheet. We'll also have this live classroom link, this Zoom channel, dispute autograder, I'll talk about that in a sec, and then the link to set up an appointment with me. All right, now, this is kind of cool. If you click on this, this will pull up an up-to-date calendar of what is available in my calendar. All right, I have a bunch of students signing up for appointments right now, but these will show all the available times. If you click on one, then it'll block it out on my calendar, and that'll be your reserved time to meet with me. Okay, and as always, if there's something that you need to talk about, you can always message me, or you know, if we need to find another time to meet, we can. So. All right, your assignments for the class, your programming assignments. Since the university changed to Canvas as the new iLearn learning management system, I actually cannot see your code submissions, okay? It uses SCORM as something to parse through your code and auto-grade it, and I cannot see those reports. You can, but I cannot. So if at any point you feel like the autograder gave you an unfair grade, you can click on this dispute autograder document, and it will teach you how to use the autograder, how you can get the best results of it. And if you feel like you didn't get a fair grade on it, then I show you how to basically print up that report, save it, and send it to me so that I can look at it and review your code. All right. And so anytime you want to dispute an autograder or dispute an assignment grade that you got for a coding assignment, there will always be this dispute autograder page that I attached here. All right. You don't have to use it. If you feel good about your grade, you feel like it was accurate, that's totally fine. But if you go through these steps and you're like, yeah, I did all this, and yeah, I know my code's working, then go ahead and locate the final code submission assignment, and then save your auto-graded report, okay? And then you'll upload that to the assignment in Canvas and iLearn. So if I clicked on modules, the first time you'll probably see that is in week 3. Yeah, so week 3 we have our submit final code, and it's not in there. So I'll make sure to add all those so that they're there, okay? All right. Any questions about iLearn, where to find stuff, how the class is going to work out, anything like that? I know I covered a lot just now, but it's all here. Most of it is mentioned in the syllabus. If I just open up the syllabus, I'm pretty sure it's all here. So we have our things to bookmark, textbook. If you want to buy it, you can. Otherwise, each chapter will just be included in the modules of the course each week. I talk about Slack and how to use Slack. There's this video on how to use it. Whoops, I didn't mean to click on that. And then just some other things. Okay, so if you have any questions about late work policies or anything like that, this is here as well. It's all in the syllabus for you. So, all right. Well, let me close this up. I don't think you guys have any more questions on it. And we are going to dive into our chapter. All right. Assignment feedback, we talked about spreadsheet for recordings, online tutors. Okay, so if you go to byui.edu and just type in tutor, the first thing that come up will be the tutoring center, and you can meet one-on-one with tutors, okay, even being as remote as you are. So that's pretty awesome. Use that if you ever feel like you're struggling and you're not getting enough help from the video spreadsheet or Slack or the chapters and it's just not clicking. Use those tutors. They're free, and you can set them according to your schedule. You can set up an appointment with them. Do the extra credit, already talked about that. Just another shout out to it. Just, it's gonna help, so. And then understand the late work policy, which is in a nutshell that I do not accept late work, okay? Canvas, if you submit an assignment late in Canvas, I have set up most of it to be, you get docked 20% per day that it is late, which means if you have an assignment due at midnight and you submit it at 12:05 a.m., it'll be 20% off, okay? So just plan for that, do things earlier rather than later so you don't have that issue. And then after 5 days late, it'll be at a 0 and I won't go back and grade things. So I do this for a number of reasons, but first and foremost, it's because deadlines are a real thing in school and in careers. And if I told my manager that I was going to have something done on Saturday and I come into work Monday morning and it's not done, it's going to be ugly, you know? And so the sooner you can be dependable with deadlines, the better. So please understand the late work policy. All right, week 1 deliverables. We kind of looked at this a little bit too. We have the syllabus quiz, computer prep, making sure that your computer meets the hardware requirements of the class, and there's a link for that in there. And then installing software, just a text editor in Google Chrome. Team formation survey, don't worry about that. Chapter 1 review questions, you'll always have review questions for most of the weeks of the semester. And then a self-assessment survey, okay? In regards to that, let me come back in here. You will notice that each week there are these reports. So the getting to know you discussion report. All right, this is just a simple quiz in iLearn. I will be verifying the accuracy of these submissions periodically throughout the semester, okay? If at any time I see that there was a discrepancy in the report compared to what was actually done in the course, you'll get a 0 for the coursework for that week, all right? But in here it just says you wrote a post about yourself that helped the classmates get to know you, was posted on time, you posted a picture of yourself, and you commented on at least 4 of the 4 peers, the posts of 4 peers, okay? So these reports will be seen throughout the semester. You'll have them for your peer review discussions, basically just saying, hey, yeah, you know, I did this in the Slack channel. So for next week, you'll have a journal report, which is just, you know, you sent me a message at the end of the week, tell me how you're doing in the course. And there's a peer review discussion report saying, yes, I posted in the peer review discussion channel on Slack. And so that's what all these report items are here in Canvas. All right. All right, chapter 1 for reals this time, now that I'm done talking about the course. So, semiconductors. Now, all this is from your book. If there is anything, it's very little that wasn't in your book that I included in this, Okay, so if you have any questions, the book goes over all of this in more detail. I kind of want to give you a high level understanding of all these different things. Okay, the way the course will work out, we'll talk about computer hardware, different parts of a computer in week 1, which is right now. Week 2, we are going to talk about programming, all right, and algorithms and how, and just basic concepts of algorithms and what programming is, all right. Week 3, we talk about HTML, and then week 4 and on, it's all JavaScript, okay. We talk about HTML because that's kind of what we are going to use to house our JavaScript and to run it in a browser. Browsers are fantastic at reading HTML files. And so if I have a doc file, I would need Microsoft Word to open it, all right? I couldn't use like my photo editor or something like that. I would have to use a document reading program like Microsoft Word. If I have an HTML file, I have to have a program that would read it, okay? Microsoft Word actually can do HTML files now, didn't used to be able to, but browsers are champs with doing HTML files, all right? And so we will use Google Chrome to run our HTML code, and then we will, in week 4, begin embedding JavaScript into our HTML files and run that in the browser as well. So back to computers. Semiconductors are microscopic parts of a computer that partially conduct or sometimes conduct fully or none or no electricity, okay? There are 5 types. There's a capacitor, this guy on the top, which temporarily stores electricity, kind of like a battery. There's a diode, which allows electricity to flow in a single direction. There's an LED, all right, which is a light emitting diode. Shouldn't be anything new to you guys, which emits light. It's just a light bulb when there's electricity in it. There's a resistor, which you might imagine resists the flow of electricity. It's to help prevent surges in electricity. And there's a transistor, which is used to amplify or can be used as an automated switch. This is what an integrated circuit looks like. Now, if you've ever seen random computer parts at like a thrift store or something like that, or a motherboard, you'll notice that it kind of looks like this, all right? And there's a lot going on there. Kind of looks like a child scribbling on paper to me, maybe a little bit more organized than that. But a circuit is composed of many, usually billions nowadays, semiconductors etched on a small piece of silicon called a computer chip. All right, so this is a computer chip right here, and you can see there's a lot going on here. We're going to talk about a couple of these components. This looks kind of like one of those semiconductors. I'm not sure if it is, but it looks like one of those semiconductors that we just saw. So a couple of different parts. We have a power supply. If you have a laptop, it's a battery. Otherwise, you just plug into the wall with a desktop computer. You have a keyboard and a mouse, which are used for user input. All right. Monitor is used for computer output, stuff that you want to output to the user. Motherboard is kind of like the hood of a vehicle. All right. Inside the hood of my vehicle, I have an engine. I have the place where I put my power steering fluid. I think, I actually don't know for sure. But my windshield wiper fluid I know is there. You know, there's a lot of different components of a vehicle inside of the hood of the car. And a motherboard is the same way. Everything connects to the motherboard that's going to be used by your computer. The bus, if I go back to our last picture here, you can see all these lines, okay? These are buses on a computer chip, and they are used to transfer data or electricity to different parts of the computer. There's the BIOS, which is used as the default configuration for booting up a computer. So as soon as I hit my power button on the computer, it doesn't immediately go to my hard drive or something like that. There is a physical place in my computer that houses the BIOS, which is just it contains the software instructions for how my computer is going to load. All right. You could have multiple operating systems stored on your hard drive. And my BIOS would be like, oh yeah, I want to load Windows, or I want to load Linux, or I want to load Mac OS. You know, that's very possible. And that would be stored in your BIOS for how your computer will boot up. Main memory, okay, often referred to as random access memory or RAM, okay? This is a temporary memory place in your computer where anytime your computer is running something, it will temporarily store data that it needs to execute a program inside of your RAM or main memory, okay? The hard drive is similar to main memory in some ways. but it's very different in the fact that it is permanent. Okay, it is a non-volatile type of memory, which means if I unplugged my computer or if I pulled the battery out of my laptop, nothing would change on my hard drive. That data is all still there. It is stored in a non-volatile state. Main memory, however, if I pulled out the battery of my laptop right now, everything that's on my desktop, gone. Okay, well, not what's saved on my desktop because that's on my hard drive, but the PowerPoint program that I have running right now, Zoom, my browser, it would all be gone and none of it would be remembered because that is stored in a volatile state in RAM, okay? But my hard drive, I have this PowerPoint saved on my computer. That's on my hard drive. So if I pulled out my battery right now and turned it back on 5 minutes later, I could still pull up this PowerPoint because it is stored in a non-volatile state. CD or DVD drive, a lot of computers don't even have these anymore, but obviously it's for reading CDs and DVDs. Jump thumb or flash drive, okay, they come in all shapes and sizes, but they can act as an extension to your hard drive or an extension to your main memory. If you don't know how to do that, it's pretty cool, you can Google it. CPU, the central processing unit of a computer, that is often called the brains of a computer. It is where the processing happens. It's where all the arithmetic happens. It's basically what kind of runs everything. So if I click on something on my desktop, that command will be sent to the CPU, will be like, hey, the mouse did this and it's requesting this, and the CPU will process that and be like, oh, well, that thing that they're requesting is in the hard drive, so I have to go get this from the hard drive. And the CPU kind of acts as like the, you know, the central processing unit, the command desk, if you will. And then cache, the cache is another type of volatile memory, similar to main memory, but used for different things. All right, data sizes. We have a bit, which is a binary number, which is either 0 or 1, true or false, okay? So if I turn a light switch on, I could consider that electrical circuit to be complete or to be true, okay? And if I turn it off, it's false. Okay, 0, 1, it's one or the other, that's it. That is a bit, it is a binary digit. And at the baseline of our computers, this is all our computers know. Bits, true or false? Billions of pieces of, billions of switches on silicon chips that are all set to either true or false, that with all of them together can form complex pieces of data like this PowerPoint or like a Photoshop program or something like that. A byte is 8 bits joined together to form a binary number, okay? So if a bit is either a 0 or 1, a byte would be like 0, 1, 0, 1, 1, 1, 0. I don't know how many numbers that was, but it would be 8 of those binary digits, okay? A nibble was probably saying at some point because of a byte, it's half of a byte, okay, 4 bits. A kilobyte is 2 to the 10th bytes. Usually we just refer to it as 1,000 bytes, but technically it's 1,024, okay? A megabyte, this is something we see very frequently, okay? But a megabyte is about 1,000,000 bytes, but technically it's 2 to the 20th, which is this number right here. A gigabyte is 2 to the 30th, all right, which is about 1,000,000 megabytes, or 1,000 megabytes, sorry. A terabyte is 1,000 gigabytes, a petabyte is 1,000 terabytes, roughly, okay? And an exabyte is 1,000 petabytes. I'm sure it goes higher than this. With how much data is being uploaded every day to the web, our measurements for this are having to continually increase. Okay? But nowadays, gigabytes and terabytes and megabytes are probably the most common thing we hear on a daily basis. So, clock speeds. All right, this is an interesting one. All right, all that data size stuff, you're like, yeah, like that's fine. I know about gigabytes, but this is an interesting thing. So the CPU kind of runs on a clock. All right, it's a small electrical circuit that repeatedly produces an electronic signal that pulses. All right, so let's say that it pulses once per second. That means that every second it's going to do something. All right, and a single core on a CPU is designed to complete one instruction at the end of each pulse. Okay, so obviously our computers are going to pulse a lot more than once a second, all right? But at the end of each pulse, it's going to do something. It's going to send out a command, an electrical current of some type, and clock speed is measured in the following. Either hertz, well, it's measured in hertz, which measures frequency equal to 1 cycle per second. Megahertz is 1,000,000 cycles per second, and gigahertz is 1,000,000,000 cycles per second. All right, so if I went into Costco right now, and I looked at their computers, I would see something about probably like 2.3 or 2.8 gigahertz processing speed or something like that on the computer, along with their RAM and the hard drive and you know, different specs. But anytime you look at the basic specs of a computer, it will show the processing speed of the CPU. And it will most likely be, it should be in gigahertz. All right, if it's anything less, just walk away, okay? Many modern computers have clock speeds of 2.5 gigahertz or higher. That is very true and extremely common. All right, but in addition to that, many CPUs have multiple cores. So if you ever have heard the term like quad core CPU, it means that it has 4 individual cores inside of that CPU that are working together. But each one will have a clock speed of whatever it is. So if I have a 2.5 gigahertz quad core CPU, each one of those cores is able to execute 2.5 billion cycles per second. All right, which is really intense, which means if I had a 2.5 gigahertz quad core CPU, it could execute 10 billion cycles per second. All right, now that might sound like a lot, and it is, obviously, it is a lot. That's a very big number. But our computers, like I said, are not very smart. They're dumb creatures. And what I mean by that is all they can read is binary, is 0 and 1. So data stored at the very baseline is just in binary. If I have a single letter, a lowercase a, it has a binary value of a bunch of zeros and ones stored in my computer. So when I click on like a PowerPoint presentation, for example, it has to grab every single letter and convert its binary value up through the machine language and then into a lowercase a for me to see, or whatever letter it is for every single one. That'll take a bunch of commands, you know, so yes, 10 billion commands is outstanding, but with some of the things our computers do, it has to be that way, so. All right, common classes of computers. We have a micro or personal computer designed to be used by one person at a time, such as a phone, tablet, computer, laptop, desktop, doesn't matter. But these are personal computers, okay? A workstation is also meant to be used by one person at a time, but it is a very powerful computer, okay? When I was working at General Motors as a software engineer for a while, I had what was classified as a workstation, okay? And that just meant that it had a lot of RAM, a really intense CPU, and it could do really complex and really heavy tasks. And these are frequently used for engineering, scientific, or medical tasks, such as designing airplane parts or things like that. I would also venture to say that they would be used widely by, you know, data analytics and things like that. And then we have a mainframe computer, which is a very powerful computer designed to be used by multiple people at the same time to perform business or scientific tasks, okay? And this doesn't mean that they're all like sharing the same keyboard, but they can all access the computer at the same time from different places, okay? Most commonly, this happens nowadays by using something called SSH, which is secure shell, and it allows you to connect remotely to a computer and perform tasks on that computer. So. All right, software. We have learned up to this point a lot about hardware, different parts of a computer, physical aspects of a computer. But those physical aspects are only physical if they don't have some instruction. So software is where that comes in, okay? There are instructions written by a computer programmer to tell the hardware what to do, okay? So types of software. We have, I'm gonna start down at the bottom here, we have an operating system, which manages the hardware. Okay, it isolates applications from the hardware so that applications don't have to directly interact with the hardware. Okay, so I have written many desktop applications or many websites and many mobile applications, and I've never once had to worry about clock speed or what's in the BIOS or different things like that. Okay, as long as I'm building it within an operating system, that's all I have to worry about. The operating system will isolate applications in such a way that Microsoft Word doesn't care what the hardware does, okay? Microsoft Word will send commands to the operating system, and the operating system will be like, oh yeah, that's like stored over here in the hard drive. We've got to send that along the bus. We've got to do this math with the CPU, whatever it is, okay? But applications, they're just pieces of software that accomplish a specific task, okay? Like PowerPoint has a very specific function to show slideshows. All right, Microsoft Word, same thing. If I want to write up a document, I mean, I can do a lot of things. Google Chrome Anytime I want to read an HTML file or access different websites or things like that, I'll use a browser. All right, a calculator, these are all applications that I can access in an operating system that work independently of the hardware, okay, because they're isolated by the operating system. All right, character data. Everything in a computer's memory is stored as a number or a set of numbers, okay? So, like I said, computers work really well with binary and not much else. So there is the American Standard Code for Information Interchange, the ASCII table, which is it's generally called because it is a table. It has 128 rows that assigns a number to each English letter and common punctuation symbol. So here's my name, Birch and Birch. You'll notice that the lowercase b is the number 98 and the uppercase b is the number 66. All right, these are the ASCII codes for each of those letters. All right, now if I went to Google and I said convert ASCII 98 to binary, so I could type in 98 and you can see there's my binary. It has this for 9, this for 8, a bunch of zeros and ones, and so we use the ASCII table a lot more than we do binary as far as like character data goes, but even that will end up converting it into binary eventually for our computers to be able to understand. Okay. Unicode is kind of like ASCII on steroids. It has everything that ASCII has, in addition to a bunch of special characters, like if I wanted to write something with Portuguese accents, or in Greek or Hebrew, Arabic, Egyptian, Chinese, all those characters are found in the Unicode table. So that's really big, lots of stuff in there. All right, execution example, okay? So we talked about this a little bit, like if I was gonna click on a file, but imagine that I have Microsoft Word, like a shortcut to a Microsoft Word document stored on my computer, or just a document, okay? If I click on that, here is at a high level what my computer will do to be able to display the contents of that file in Microsoft Word to me, the user that clicked it. Once I click on it, first, the operating system commands the hard drive to copy the Microsoft Word application into main memory. All right, remember main memory is our RAM. So the application itself, Microsoft Word, has to be in our temporary memory inside of RAM to be able to function, okay? For whatever reason, inside of the hard drive, it can't just run from there, okay? So the application itself is stored there, but it will be copied into RAM, into main memory, so that it can run, all right? Once that operating system commands that to happen, the hard drive copies it over a bus into main memory so that it can actually be in main memory. After MS Word is in main memory, the operating system executes Microsoft Word and sends a command to Microsoft Word telling it to open the document that the user double-clicked. Then Microsoft Word requests the operating system to read that document from the hard drive and place it in main memory. Okay, so the document itself also has to be in main memory for it to be able to run, to be able to be opened and shown to the user. The operating system copies it into main memory. Then the hard drive copies the document file over a bus into main memory. For each character that is in the document, Microsoft Word reads the character's Unicode number from main memory and requests the operating system to draw that character in a window. The operating system finds the Unicode number and its corresponding symbol in a table and draws it. All right, for every single character. So the fact that I can pull up a PowerPoint presentation like this in like a second, or a Word document with 20 pages in like a second, is pretty incredible, considering everything that has to happen and how much communication has to take place inside of our computers. Okay. But that is, in a nutshell, and at a very high level, how our computers work and how they function. And that's also where we come in as programmers to be able to write software to tell our computers to do different things. Okay, just to give you guys a little taste of what we're going to be doing next week, I already showed you my Visual Studio Code program right here that's used to write coding files. All right, this one is called 3.1.html. This is a file extension, just like if I had a PPT document for my PowerPoint or a docx for Microsoft Word, whatever. This is just an HTML file. All right, well this, I can copy the file path. I just right click up here and copy the path. And if I paste it right here just to show you, you can see users, Birch25, it shows the path of where this 3.1.html is stored on my computer, okay? But if I instead put this into my browser in the URL, Then I'm telling my browser, hey, I have an HTML file on my computer. I want to execute it. I want to open it up in Google Chrome. Well, if I run it, here it is. That code being rendered by my browser. All right, and we're going to dive into this in week 3, but this is a very good example of software being executed inside the computer, obviously using the hardware components of the computer to function properly. But this is what we'll be doing all semester long. So, do you guys have any questions? That was all I had for you today. Do you guys have any questions about clock speeds, software, character data, programming, anything?
With the VS Code or the other one that you were talking about,
Yeah.
you recommend either one, or do you like Sublime a little bit better?
I love them both. I love them both. Recently, I've started using VS Code more, but that doesn't mean it'll be the best for you. Here's why I've started using it more. VS Code has a nice little button right here called extensions. I can click on that, and if I decide I want to download a JavaScript extension, which will help me, to be able to code more accurately or whatever, I can download these extensions with a click of a button, and it's really, really, really easy. Okay. We're not really going to be using those very much in this class. Okay. Sublime is also very capable of downloading extensions. It's just a little bit more cumbersome. It's a little bit more work to install them. But I love Sublime. I love it because of how simple it is. Okay. When you open up Sublime, there'll be less going on than there is here. It'll just be a plain black window, and you can just start coding. So they're both really good, and I recommend either. A lot of my videos will be recorded with me using Sublime, and a lot of them will be using Visual Studio Code. So both can do the exact same things, and so it's just a matter of preference. But so yeah, if you want more information on that, I'd say go to our video spreadsheet that's in the syllabus, and you can watch this, and I talk a lot more about them, and I give like demos on each of them and what they do and why I like them. So great question, Colt. Okay, anything else before I let you guys go? Okay, well, you guys, I hope that this was helpful for you. And if you have any questions, just shoot me a message in Slack, and I'll talk to y'all soon.
Thank you.
Okay, thank you. Talk to you later. Bye.